After all, mastering the foundational powers of physics to breathe life into every modern invention is pretty freaking awesome. So today we're going to reveal everything you need to know about mechanical engineering, the real-life equipment and software used in the field, what to watch out for in the college curriculum, the absurd compensation, and the subtle secrets that every mechanical engineer needs to know. Now, it's time to discover what it means to be a mechanical engineer and give it to you straight. This is the reality of mechanical engineering. First, let's start off with a little context. What actually is mechanical engineering? Well, it's using the principles of motion, energy, and forces to progress any physical object from design to manufacturing to the marketplace, ensuring that designs function safely, efficiently, and reliably, all at a competitive cost. Which is a crazy broad definition that is fitting for a crazy broad field. So let's break it down into a few bite-sized pieces. Start by picturing yourself designing the body of a massive spacecraft, simulating the aerodynamics of the vessel as it ascends through the atmosphere. Imagine yourself walking through that empty shell, knowing that soon astronauts will be floating around in it thousands of miles from Earth. Or maybe that's not your thing. Maybe you'll design the next breakthrough engine for Formula 1 racing, experimenting with chemical reactions to pioneer the most extreme of purposeful explosions, throttling your car right into first place. Or maybe you're more into mechatronics and robotics and you want to team with electrical and software engineers to create the latest futuristic innovation to harness the evolving power of artificial intelligence. I think you might be starting to get the point. There are a lot of options available to you within mechanical engineering. Aerospace, mechatronics, manufacturing, and a whole plethora of other career paths. Now don't worry, we'll explore each of these in more detail, so make sure to stay to the end of the video to hear about them and their unequal salaries. But before we get into the exciting reality behind mechanical engineering, we need to explore its roots to see what these engineers actually learn to become machinery wizards. So let's do exactly that. It's time to explore what to expect in your mechanical engineering degree. Now, I'm sorry to break the news to you, but that fancy piece of paper at the end of the tunnel requires getting through some pretty tough courses. The degree starts with your standard math, physics, software, and chemistry courses to build a base for the rest of the degree. And once you get through this first stage, give yourself a pat on the back because a whopping 40% of engineering students do not make it past this dreaded first year. If you want to make sure you're not one of the dropouts, make sure to subscribe for all the best tips and tricks for not only passing but dominating your way through engineering. Anyways, once you do finish that first year, you'll move closer to the more exciting mechanical-focused courses. And we'll start that list with manufacturing. These courses are super important whether you specialize in manufacturing or not. But why, you might ask? Well, no matter if you're designing spacecraft, iPhones, car engines, or air conditioning systems, every single object needs to be manufactured somewhere before it's sold or used. For example, imagine you're a mechanical engineer at Apple working on the next iPhone. You've done your diligence, studied the product well, and used your manufacturing knowledge to design a brand new connector that links the battery to the rest of the phone more efficiently. This fantastic idea of yours ends up shaving off a full second of the previous 35 seconds that it took to produce the iPhone, which ends up saving the company 78,000 hours of production time on the annual 280 million produced units. Can anyone say six-figure bonus? So, needless to say, you should take great notes when studying up on manufacturing processes, production systems, and supply chain management methods, because you never know when it could come in handy. But as useful as manufacturing topics are, they wouldn't even be remotely relevant without materials. Every single produced object is made up of specific materials. Skyscrapers have steel and concrete, Tesla batteries have lithium and copper, and ping pong tables have wood, laminates, and some steel and nylon. Mechanical engineers have meticulously perfected each product by optimizing for material strength, thermal distribution, electrical and chemical properties, or well, just wanting to use something soft and cheap as a net when playing ping pong. To learn the art of picking the best material for any application, students cover everything from atomic structure and bonding to corrosion, processing, and the rabbit holes of properties of materials. You might think that there are already enough mechanical topics for a degree's worth of information, and you'd probably be right, but it doesn't stop there. Up next, we have maybe the most infamous and challenging courses of all, the physics and mechanics classes. These take you from the basic kinematics of a predictable curve of a baseball throw to all of the skills you'll need to ensure submarines don't get absolutely pummeled under pressure over 400 times that of our atmosphere. And taking it from deep underwater to high in the sky, you also learn the skills to identify how much thrust is needed to lift the entire 300,000 plus pounds of Boeing 707 MAX off of the ground. In case you're curious, it's in the ballpark of 210,000 pounds of thrust needed from the engines. These skills come from all types of courses, lecturing on mass, momentum, forces, velocity and acceleration, laminar versus turbulent flow, and many more topics. You'll have a ton of fun solving these problems in lab, but we'll also have to learn the trigonometry and other math behind identifying forces, momentum, and energy in rotations, beams, trusses, and yes, turbofan engines. And if you're lucky, you'll get to use real-life equipment like benchtop engine models, wind tunnels, heat exchangers, and refrigeration trainers. All lab equipment that you'll likely use in your career. Of course, this also comes along with aerodynamics and structural modeling software that breaks down how gases and liquids react around very relevant objects, and how structures react to various stress, heat, and vibration forces to ensure their strength and stability. Yep, a whole plethora of hard skills to slap right on that resume. But what if you wanted to use these hard skills to design your own invention, to kickstart your own personal dreams and aspirations rather than being hired and developing someone else's? Personally, I've been throwing around this idea of launching a startup with a friend of mine, and PatSnap, the sponsor of this video, has been immensely helpful. They are literally the AI-powered platform that every engineer would kill for. I kid you not, mechanical engineering is the perfect degree to plan, draft, and actualize your own invention, but how do you know if your idea is taken? What companies are you competing with? What relevant patents are out there to build your design off of? Hero, PatSnap's AI assistant, answers all of these because it's uniquely trained on proprietary innovation data, meaning you get reliable answers linked to patent and non-patent literature when asking your engineering questions. I mean, just look at all of these actionable strategies for designing a hydraulic arm. Here's a result for low cost and convenient repair. Now we can see mechanical grabbing and gripping patents completed with diagrams and further information. And over here on the literature page, we see white papers and other documents chock full of all sorts of useful information. But don't just take it from me. No matter if you're a student deciding on a senior project, a hobbyist looking for help with your design, or a senior research and development engineer diving headfirst into proof of concept research, I implore you to try PatSnap for free with the link in the description below. You literally have nothing to lose. Seriously, this is where the future of engineering is going, and you'll be glad that you hopped on the train early. I know I am. Anyways, thanks to PatSnap for sponsoring, but we gotta get back to the video. We only have one last section of the curriculum, and it just might be the coolest of them all. Robotics and mechatronics. This is where you really start to see everything come together, as students use mathematics and physics to figure out how the robot will move, electronics and programming to control the robot, and modeling software to make sure everything looks good before it's built. Here, students spend an entire semester designing a robot from scratch to accomplish some task like quickly racing down a track, sorting items, or maybe even fighting to the death. But this is also one of the toughest courses because it heavily relies on not only the mechanics that you've become so fond of, but also electronics and programming. And now you're almost out of it, but have one final boss, the capstone course. A year-long endeavor in which you piece together a diverse team of engineers with the goal of designing innovative, problem-solving projects like strength-amplifying exoskeletons, roaming ocean-cleaning robots, or a new, more efficient delivery drone. Now, congratulations! You're done with the degree. Not that you have any time to rest. By now you've surely already lined up a job, right? Whoa, pump the brakes. Now, you should know by now that we have everything you need to get that dream job on our channel. But what jobs are actually even out there for mechanical engineering graduates? Well, I'm glad you asked. To see what you can actually do with your degree, let's check out the 9 most common mechanical engineering careers, their salaries, and then wrap up with the 2 most important things you need to know before entering the field. Starting it off, we have a channel favorite with aerospace engineering. These engineers use all the topics we covered to design aircraft and spacecraft in and outside of the atmosphere. Although it comes with a really competitive job market, these engineers make a booming average of $121,000 a year in the US according to Glassdoor. Back on Earth, you'll find HVAC mechanical engineers working on climate control systems from airplanes to Antarctic research stations. These engineers focus aerodynamics, thermodynamics, and manufacturing machinery, and for their efforts also make an average of $121,000 a year. Next up, we have another channel favorite, the growing career field of mechatronics and robotics. Another wide field with various subfields in it, these engineers are more comfortable working with electrical and software systems to design anything from autonomous driving of Teslas to the newest, fastest racing drones. These engineers are experiencing the fastest growth of all careers on our list today, and with it an increased pay, making $128,000 a year on average. Finally, we have manufacturing engineers that use in-depth machinery and materials insight to deal with the production processes for every and any product, which pull right around $112,000 a year. Now, we have a few more mechanical subfields and salaries that we'll list at the end of the video, but this list is getting a little long and we need to tell you how to increase your wage and the most important skills you need today as a mechanical engineer. So to start, when you enter the field as a level 1 mechanical engineer, it might be tempting to take an easy, chill position, but this might result in a job that pays the bills but isn't challenging enough to provide a path to the next step in your career. In other words, if you're interested in maximizing your potential, salary, and being able to land any job that you want, make sure to find a position that actually challenges you and provides training for skill growth. Further, obtaining relevant certifications in your subfield and developing high-level project management skills always raise that salary potential, along with a master's or a PhD if you're interested in taking that route. But what skills are you to focus when preparing for jumping into your mechanical engineering career? This definitely depends on which subfield you go for. Like, structural engineers need strong finite element analysis skills, and manufacturing engineers should be coming to terms with 5-axis machinery. But in general, CAD modeling, MATLAB programming and modeling, and rock-solid understandings of mechanical engineering basics, like mechanics, thermodynamics, and materials, are very important no matter what field you get into. Now, congratulations! You know what to expect in the mechanical engineering degree, what the most common careers are with the final ones here, and the most important skills to adopt when entering the field. Now, with all of this in mind, do you want to be a mechanical engineer? Let us know in the comments below. We really appreciate you staying through the whole video. Please, if you've learned anything, help us out by leaving a like, and make sure to check out other videos and subscribe for other mechanical and general engineering insight. Thanks for watching, and happy engineering, everybody!